Okay, so there's a couple of things going on here, a few things. Kim is extending a $6,500 note to Sam, 6.2% for 120 days. And then Kim is discounting that note to the bank. Remember, this was the long process from last class where we have to figure out the terms of the original note first. Then we're using that and that discount note to the bank. Now I added a third piece into this, the effective rate on the discount note. We're going to ignore that for now and we'll come back and look at that at the end. So let's work on finding Kim's proceeds. To find Kim's proceeds, the first step is to find the maturity value of the original note. It is, first step is going to be to find the interest. P is $6,500. What's R? 0.62 because it's the original note. And then times 120 over 360. So 6,500 times 0.062 times 120 over 360. $134.33. So then we use that to find that maturity value by simply taking the $6,500 principal plus the $134.33 in interest. You get $6,634.33 as the maturity value of the original loan. So that's the number we're basing the discount to the bank on. Now we need to find some dates. In your little magic chart on page 396 in your book, what number of the year is May 7th? 127. The other date we have is June 13th, which is 164. We need those dates because we need to figure out step 2, which is the discount period. Now remember, the discount period is the days left, the days that the bank is going to hold the note. So we look at the dates we have up here, the 164 minus 127. Which gives us 37 days, right? That's the number of days that have gone by already. We need to take the term of the note of 120 minus 37 gives us 83 days left. That's the time that the bank is going to be holding the note. Now I'm going to stress this. Make sure that you are finding the number of days left and not the days that have already gone by. Number one mistake made on these problems on the third test coming up is that you find the number of days that have gone by, but you forget to go back and subtract it to see how many days are left. $83 is the discount period. All right, so there's only one period. I don't need an S on there. Next, we're going to find the bank's discount. That is going to be found using the maturity value of that note, 6634.33. Why do we use the maturity value of that note? Yeah, because that's what they're actually borrowing against. The original note is going to end up at that amount, and that's what they're borrowing against to the bank. The bank was, what, 7.9%, so 0.079. Just to make sure, 7.9%, yep. And that's times 83 days over 360. So 6634.33 times 0.079 times 83 divided by 360. 120.84. $120.84 is the bank's discount. So final step is find the proceeds. And that is going to be found by taking that maturity value, which is the face value of this discount note to the bank, and subtracting the bank's discount. Which is $6,513.49 is Kim's proceeds. So Kim gets their money back plus $13.49 in interest. The bank gets the rest. Now, the second question I asked is to find an effective rate. Anytime we are doing a discount note, the effective rate of interest is higher than the stated rate of interest because you don't get all the money. If Kim had received the full $6,634.33, the effective rate would still be the 7.9%. But Kim didn't get all of it. Kim only got this much of it. That $120.84 is 7.9% of the 6,600, not the 6,500. So the effective rate is found by going back into our simple interest formula. I equals PRT. We are going to replace I with that discount, $120.84. P is then going to be the proceeds, because that's the amount that Kim actually received and was able to use. Then we have R, and the time is 83 out of 360. Because that's how long the bank held that note. So now we have to combine these two numbers on the right side. So I'm going to take $6,513.49 times 83 divided by 360. And this might come out to be an ugly number, and it is 1501.72. Now note, I am not going to hit clear on my calculator. I'm going to leave that on my calculator screen, because now is where I'm going to use that little answer key, answer trick, to keep that in my calculator to get an exact answer. Now to solve for R, I am going to divide by that amount. What I'm actually going to do on my calculator, however, is I'm going to type in 120.84 divided by second answer. 0.0804. Remember we said go at least 5 decimal places? So 0.08047. To turn that into a percent, move the decimal point 2 spots. That's 8.047%. If I wanted to round that to the nearest hundredth of a percent, that's 8.05%. So that 7.9% really is 8.05%. Any questions there? Can you not do for effective rate? What they do in the formula they use, they have it automatically solved so that R is equal to your interest over principal times time, like that. But to me, I'd rather have one formula memorized and do a little bit of algebra to solve it than have to memorize a whole bunch of different formulas. You got her? You are allowed to smack him on break, just as long as I don't see it, just so you know. Okay. What we have been doing so far is simple interest. Simple interest. We had the two things. We had simple interest note. And we had simple discount note. Remember, the difference was simple interest, you started out with an amount, you added the interest to it, so you paid back that amount plus interest. And the simple discount note, you named an amount that you wanted, but they took the interest out and gave you a lesser amount. And at the end, you paid back the face value. But either way, they are both simple interest. Both of them, interest is only calculated when an action occurs on the note or at maturity. In fact, for a simple discount note, they usually don't allow any actions on the note until maturity. You're not allowed to do partial payments or things like that, just because it is kind of complex to calculate those partial payments on a simple discount note. Notice we did not do partial payments on a simple discount note. I don't hate you guys that much. You pay everything at the end, yes. But remember, the amount you pay back is just, if it's a $10,000 note, you pay back $10,000 because you're only going to get $9,000 and whatever. We did on the simple interest note, we did those partial payments. But remember, interest was only calculated at the time you made the payment. You calculated the interest before you could adjust the balance of the payment. So anytime something changes the balance of the note, the loan, then you calculate the interest. Another characteristic of these is usually it's a single payment. So it's either a payment or a loan. Then there's a period of time, and then there's a maturity. So you're either collecting your money or you're paying back the loan. Like I said, we did have those partial payments with the US rule. But for the most sake, simple interest, the biggest thing is simple interest has no scheduled times to calculate interest. The interest is calculated when you do something, so you can control when interest is calculated. Well, what we're going to be moving on to tonight is called compound interest. Compound interest has the same quality. There is a balance at the beginning and there is a balance at the end. And the only thing that happens in between is interest. There are no payments made in between. If there are payments made in between, you have to do a complete calculation. You basically end the note, make the payment, adjust the balance, then do it again. Just like we did with the US rule for simple interest. The biggest thing here is the interest is calculated at regular time frames. Yeah, usually monthly, quarterly, annually, whatever. The interest will be compounded. It will be figured every now and then. This beginning balance, since usually that's where we're at right now, is referred to as the present value. The ending balance, something we're going to have at some point in the future, is called the future value. So what we're going to start out with is we're going to start out with finding future value. How do we look at a problem and know that we're trying to find the future value? Well, because we have to be given the present value. You may not necessarily be told the word present value, but you know it's the present value because that's the amount of money you have right now. If the problem says, Pete wants to invest this much money, well, that's how much money Pete has now to put into the investment. How much will Pete have after 7 years? Well, 7 years is in the future. We're looking for the future value. So let's take a peek at how this works. We've dealt with our simple interest. We've dealt with percent increases. It all comes together here with this compound interest. In the past, let's say that let's say you're going to earn 2% interest for the year. On $5,000. We dealt with this table before. We have a beginning value, right? Otherwise known as the present value. To that, we're going to add the interest, which will give us an ending value or a future value. If we look at the percent sign and the dollar side, right now we're given the $5,000, which is the present value, the beginning value right now. And we're given the 2%. But we also know the beginning value is 100%. Which makes the ending value 100 plus 2 or 102%. So if I want to find this ending value, I don't have to find 2% added on. All I have to do is find 102%. Now this is where we're going to go back to use that rate method. We're going to take the $5,000 times 102% as a decimal is 1.02, right? So that's $5,100 is that ending balance. Does that look familiar? Vaguely? Like something we may have seen at some point before? Okay. Next. Sam invests $5,000 at 8% compounded quarterly for 3 years. Let's look for the future value. Well, using what we already know, There are some things we can do with this. We can find, first of all, in quarter one, the amount of interest is $5,000 times 0.08, but it's a quarter, so times 1/4, right? Which gives us $100 in interest. Does that look right? So that means the ending balance is $5,100. So then in quarter two, I'm going to start out with the $5,100. What's that end up being for interest? What'd you get? $102. Perfect. So you get $5,202 as your ending balance, right? How many times are we going to have to do this to make it to the end of 3 years? 12. Quarterly means 4 times a year. So for 3 years, that'd be 12 times. I don't know about you, but I don't want to do this 12 times. So it's time to look for a shortcut. First, let's look right here. 0.08 times 1/4 occurs in every one of those interest formulas. 0.08 times 1/4 is 0.02, which means each period we're gaining 2%. Now that makes sense. There is something referred to as the rate per period. That is the annual rate, APR, divided by N. N is the number of periods in a year. So in this problem, that's 8% divided by 4 because it's quarterly. We found that percent and we added it on each time, which means we're doing exactly what we just did up above. We're taking 100% plus 2% to get 102%. So let's check that out and see if that would have worked. Could I have taken the $5,000 and multiplied by 102% or 1.02? But yeah, that would give me 5,100. If I took that 5,100 and multiplied by 1.02, I do get 5,202. It gives me the same ending balance. Yes. Yep. Oops. That's a misprint. That should be 1/4. Thank you. Thank you for catching that. The little hamster is running in circles tonight. Yes, that should be 1/4 because it is 1/4 of a year. I don't know where 8 came from there at all. Probably from the 8%. So now all we have to do is multiply by 1.02 to get the ending balance at the end of each quarter. How many times do we have to multiply by 1.02? 12 times. In math, do we have a mechanism for multiplying by the same number over and over again? It's called the power. 5,000 times 1.02 to the power of 12 is 6,341.21. Okay, so on your calculator, you would punch in 5,000 times 1.02. And then you've got a little caret key that looks like that one. Yours is over on the left, about halfway down. Looks like this. Yep, so hit that and then type in 12 and press equals. Get 6341.21. Perfect. Now let's see where this little equation here came from. First of all, what we found here was a future value. That's the amount that will be had in the future after 3 years. So this is a future value formula. Because we are finding the future value. To find the future value, we took the $5,000, which was the present value. That's what we have right now. And we multiplied it by 1 plus 2%, right? 102%. The 1 stood for 100%. The 2 came from our annual percentage rate, which I'm going to call R, divided by the number of periods in a year. We had 8%, but we divided it by 4 periods in a year because it was quarterly. So R, I'm going to make a little list down here. R is your annual rate, which is your stated rate. They always give the annual rate. So it's whatever your stated rate is. N is the number of periods in a year. So compounded quarterly, it is 4, because there's 4 periods in a year. Compounded monthly, it would be 12 months in a year. Compounded semi-annually, 2, because there are 2 periods in a year semi-annually. To the power of n times t. What this thing is here is the number of periods, total number of periods. N was 4 periods a year, T was 3 years, that meant 12 periods total, right? So I'd do it 12 times. This number down here is what we said before was our rate per period. The rate divided by the number of periods in a year. So it's example time. Up a little bit, Mercer. I'll give you that in a second there. We have 2 more. The 20th, I believe. I'll try to. Yep. So that one you can, but you've got to get them back right away. So let's say Pat. Usually what I do is I accept corrections up till the end of the day on Friday, so you've got that day off of classes to work on them too. Let's see, Pat invests $4,300 at 5% compounded monthly for 6 years. Find the future value. So now remember, the future value here is equal to the present value, which is 4,300 times 1 plus 5% is 0.05 divided by how many periods are in a year in this one? 12, because it's compounded monthly. So 12 periods in a year to the power of 12 times 6. 12 periods in a year times 6. Now, normally, just to make it easier to punch in my calculator, I figure that number out to be 72. Exactly. It's a lot easier to enter in my calculator if I do that. So, race me to it. And yes, you do have to put parentheses in here. Oops, I screwed it up, so you're probably going to beat me. Did you get $5,800.78? No. We have to punch in your calculator again. Remember, 4300, and many of your calculators you have to put times in there. Some of them you don't, but to be safe, put in the times. Then the open parentheses. 1 plus 0.05 divided by 12. Close the parentheses, the caret, the little power key, and then 72. Hit equals. Did it work? Cool. Anybody not get it to work? Yours isn't working yet? What calculator do you have? Okay, so that one, let's just walk you through it again here, Anthony. So 4300 times, open parentheses, 1 plus 0.05 divided by 12, close parentheses. Now you've got to hit that caret key. It looks like this. It's on the left side of your screen, about halfway down, I believe. And then 72. Did it work that time? Okay. Yeah, the big mistake a lot of people make is they try to hit the X squared key and then 72. And that won't do it. Let's have you guys try one. Alex borrows. Notice it doesn't matter whether they're borrowing or investing. It's still a future value and a present value. Alex borrows $13,800 at 9.1% compounded quarterly for 6 years. How much will Alex pay back? I'll give you a couple minutes to work on that. Let's check it out. So we are looking for a future value. What's our present value? 13,800 times, parentheses, 1 plus 0.091 divided by 4, power of 4 times 6. And again, I'm going to cross off the 4 times 6. Just put in a 24. So 13,800 times 1 plus 0.091 divided by 4, power of 24. Did we get 23,687.10? Now here's my next question. How much interest does Alex pay? Now here's one of the things that's backwards in compound interest. When we did simple interest, we always found the interest first, then you added it on, right? Here we find the ending amount. To get the interest, we have to subtract the beginning amount. The difference between the future value and the present value has to be interest. You got a little dyslexic on me there. 988710. Did I write it down? Oh, it is 78. I wrote this. I was dyslexic. Wow. How's that? Is that better? Okay. I have explained to you guys that I am dyslexic. Right? When I get tired, I do switch things really bad. What's that? Do as I say, not as I do. The sad part is I write down all the wrong numbers and I still write down the right answer. Okay, so I'm going to have you guys try one more on your own. It's going to take us up to break here. Peyton invests $1,900 at 5.8% compounded monthly for 2 years. How much interest does Peyton earn? It is 6:20, so let's take our break. We'll come back at 6:30 and we'll see if you got it right. Yes. We have to find our future value, which is going to be our $1,900 present value times 1 plus 0.058 divided by 12, because it is monthly, to the power of 12 times 2, which is 24. So I'll put the 24 in there. So when we punch this in, it's 1,900 times, parentheses, 1 plus 0.058 divided by 12. Close my parentheses, the power of 24. 213310. Of course, that's our answer, right? No, it's not. What do we still have to do? Subtract 1,900 to get $233.10 in interest. Any questions? Okay, well, there is a happy little table in the book. Which I believe is on page 463. Got to make sure I've got the right page for the new edition of the book. That's the one we're looking for. So it's future value, compound amount of $1. There's like 3 of these different types of tables in this section. So we will have to keep them straight. Yes, this one is the future value compound amount of $1. You'll notice the way this table is set up. Across the top, there are percents, and they're listed as rate per period. Now, we've talked about that a little bit. We'll explain it a little bit more in just a second. On the far left is periods. Now, the problem we just did would not be found on this table because our rate per period would be 5.8% divided by 12. That's not on this table. You'll see the table is listed to the nearest 0.5%. So the reason why we learned the formula first and not the table is because the formula always works. The table will only work for very specific problems where the percents work out. For example, the problem we did before that was $5,000 at 8% compounded quarterly for 3 years. Our rate per period for that one was found by taking the percent, 8%, divided by how many periods in a year? 4, because it is compounded quarterly. That gives us 2%, which means we would be looking for 2% up on the top of that table. Our number of periods is just what we use for our power in the formula. That is just n times t. So that's going to be 4, because it's quarterly, times 3 years, which is 12. So on the left side of the table, we're looking at 12 periods. We're going to trace them until they come together. 2% and 12 periods give us 1.26824, correct? Any questions on where I got that 1.26824? 463. So, because you're finding a future value. And this says future value of or compound amount of $1. You can do the formula instead, yes. So now to find the future value using this, you would take that $5,000 times the 1.26824, which is going to be 634,120. Is that correct? If you use the formula, it's 21. If you use the formula, this is 5,000 times, parentheses, 1 plus 0.08 divided by 4. I'm just going to put the power of 12 there because we know it's 4 periods here times 3 years, right? So that's going to be 5,000 times, parentheses, 1 plus 0.08 divided by 4, close parentheses, power of 12. 6341.21. You are correct. Now you'll notice that's off by a penny. Which one is more exact? The formula, of course. The table is rounded off to only 5 decimal places. The larger the number is and the longer the period of time is, the more the table is going to be off. Now, unfortunately, my math lab uses about 2/3 of the problems they use the table, and about 1/3 of the problem they use the formula. So I will allow you to use the formula on all of them. It's just if you get your answer and you're off by a penny or two, some of them are off by as much as like 40 or 50 cents. It's because you use the formula. So on the homework, don't worry about it. On the homework, I'm going to assume that's the problem and just give you the credit for it. On a quiz, if it marks one wrong, I have to go through. This is where these last few quizzes, I have to go through and grade them manually. So don't worry about it on a quiz. If you get really excited, you can send me a message and say problem 7, 3, and 9 on the quiz. It looks like it's just a round off for me using the formula. Yeah, it shouldn't be that bad, hopefully. But I will double check the quizzes and make sure that if you did the formula and it marked it wrong, it's because it's the formula, not because you did something wrong. But yes, and you can see your own answers too. When you go back in and look at a quiz, by the way, what it shows in the box is the correct answer. If you take the mouse and hover the little mouse cursor over the top of it, it'll then show your answer in the little pop-up window that comes up. Yes, should be able to. So if it's more than a few cents off or more than 50 cents off, you may want to look at it more closely and make sure that you didn't make a mistake somewhere else. Yeah. Sure. Okay, so now next, just like with our simple discount notes, we had that effective rate. The effective rate was always higher than the stated rate because you didn't get the full amount. With compound interest, there's also an effective rate because you're getting interest on top of the interest. Oh, we've got 3 more weeks of a wait, there's more. So. Free for a few dollars more. I don't know if any of you remember that. It used to be a commercial for Clint Eastwood movies. One of his movies was for a few dollars more. And that was always the big catch. And your gift for ordering now, free for a few dollars more. So effective rate, when we're looking at compound interest, is always going to be slightly higher, slightly larger than the stated rate. Now, slightly could be a couple of hundredths up to, close to 0.5%, depending on how often it's compounded and how big the rate is. There are 2 cases we have to worry about. If the time of the loan is less than 1 year, we use the actual time. If the time of the loan is more than 1 year, we use 1 year. What on earth does he mean by that? Yes, if it's 4 years, you use 1 year. It's more than a year. If it's more than a year, you use 1 year. If it's less than a year, you use the actual time. I know. Give me some time. We'll get you back there, hopefully. So find the effective rate for $5,000 invested at 6% compounded monthly for 8 months. This is less than 1 year. What will we use for the time? Use the actual time, which is the 8 months. Bless you. So that means we're going to find the future value. The future value is going to equal our present value, which is 5,000 times 1 plus our rate, which is 0.06, divided by how many periods are in a year? 12. It is compounded monthly. Now here's the tricky part. N is still 12, right? What's T? 8/12 because it's in months. What's this number come out to be? Well, 12 times 8/12 says the 12's cancel out, you're left with 8. Which makes sense. If it's compounded monthly for 8 months, how many periods are there? There's 8 months. It's 8 periods. Okay. So you don't have to necessarily do the 12 times 8/12. You can just use some common sense. Well, because there are some people that idea of that being 8 periods is tough to really reason out. So you can use it monthly, so it's 12 times the time is 8 months, so it's 8/12 of a year. Just like with our simple interest, the time always has to be in years. So we're going to figure that out. 5,000 times, parentheses, 1 plus 0.06 divided by 12, close parentheses, power of 8, equals 5203.54. Now we'll pause. Is everybody able to get to that number? Any questions on how we got to that number? Okay. Yes, on the test. I have it figured out both ways, formula and table. 5203.54. That's the result so far. We haven't got to the answer yet. So that's the future value. That would be step 1. Step 2 is to find the compound interest. Well, the amount of compound interest is 5203.54 minus 5,000, otherwise known as $203.54. Step 3 is an effective rate. Effective rate is always found using what formula? I equals PRT. Very good, Kyle. So that means the interest is the $203.54. The principal is $5,000. The rate is what we're looking for. What's our time? 8 months, so 8/12. So we have to combine the 5,000 and the 8/12. This is going to be another one that we're probably going to have to leave in our calculator, because it's going to give us 333.33, right? 3333.33. So to solve this now for R, we need to divide $3,333.33. So again, in my calculator, I'm going to 203.54 divided by second answer, right? So I don't have to type it back in. I get 0.061062. Now I move my decimal point to make it a percent. 12, that's 6.1062%. And now I need to know, where do I round it to? Well, if I don't tell you where to round it to 1/100th of a percent, 2 decimal places. So 6.11. Yes. Yep. Type in the 203.54 divided by, yep, 203.54 divided by, and then second, or shift, and then the ANS key is down by your equal sign. Should say ANS above it. It's your negative key. Press that and then hit equals. 0.061. Here, let me come give it to you. Let's do a couple more. Or let's have you guys try one. Do you want to see another example or two before you try one on your own? We're not there yet. Don't get excited. We'll get there. Yes. Yeah, we'll round it off when we write it down, but we should keep it in the calculator and reuse it from within the calculator. Otherwise, it's going to set us off by a couple of hundredths on our answer. Okay, what model calculator do you have? Okay, so on yours, like you punch in the 5,000 times 8 divided by 12, and you get that 3333.33333. You're just going to leave that on your screen. Now you're going to type in the 203.54, then divided by, then up in the upper left, you either have a second key or a shift key. Press that, and then down by your equals key, you have a negative key that looks like this. It says ANS above it. So you'll press that key, and it should just bring up ANS there. Then if you hit equals, it should pop up the 0.061062. Did it work? Perfect. Anybody else have any questions? Okay. So now let's take a look at Sam borrows $7,100 at 8.3% compounded quarterly for 9 months. Find the effective rate. So what's our first step? Find the future value, right? So that future value was going to be found by doing what? The present value is 7,100 times 1 plus 0.083 divided by, now this is where you look at the compounding, 4, because it's quarterly. Very good. So it's divided by 4 to the power of, now some of you can look at 9 months and say, how many quarters is that? 3 quarters, because a month is 3 months, or a quarter is 3 months, so 9 months would be 3 quarters. If you didn't see that, you can say, okay, it's quarterly, so it's 4 quarters a year times 9 months would be 9/12. If you calculate that out, that's going to come out to be 3. 4 times 9 divided by 12. So we find this future value. $75, $51, $21. I'll pause, make sure everybody gets to that point. Okay, see, most of the pencils will stop going. So the next step is to find the compound interest, which is simply the future value minus the present value. So $451.21. So this is future value minus present value. And the final step, the effective rate. Yes, we're using I equals PRT. 451.21 is our interest. Our principal is 7,100. We are looking for the rate, and our time is 9 months, 9/12. So first we have to combine the 7,100 times 9/12. This one should come out to be a relatively easy number to work with. There it is, 5325. Times R is equal to 451.21 yet. Our next step, yes, we're going to solve for R. R is multiplied by 5325, so we're going to divide by 5,325. So it's $451.21 divided by $5,325. Now we get 0.084734 equals our rate. We move the decimal point to make it a percent, 8.4734%. And if you're not told, we always round to the 100th of a percent. So 8.47%. You guys ready to try one? Find the effective rate for $6,000 at 8.8% compounded monthly for 6 months. I'll give you guys a couple minutes. So step one is to find the future value. So that'd be 6,000 times 1 plus 0.088 divided by 12 to the power of, it'll be 6. Again, if you had to, that could be 12 times 6 twelfths. 12 periods a year times 6 twelfths of a year. It is 6 periods. If we punch that in, we get 62, 68, 89. Step 2 is find the interest. So yes, we subtract the present value to get $268.89. And then finally, we will plug this into I equals PRT to get the effective rate. So 268.89 equals 6,000 times R times 6 twelfths. 6,000 times 6 twelfths. That kind of works. There we go. Is just 3,000. So we divide by 3,000. So we do get 0.08963. Move our decimal point to make it a percent. 8.963. And then we round it to the nearest hundredth. 8.96%. Okay. How many of you had 8.96%? Show of hands. Okay. So it's going to take a little more work here. How many of you would have had it if I gave you a little more time? Okay. Okay. Well, let's do some more examples then if we're not quite there on those. Find the effective rate for $7,000 invested at 5.3% compounded quarterly for 12 years. I'm going to give you guys a chance to work on that one by yourself. Before you get too far into this, I'm going to let you off the hook. What's different about this one? It's more than a year. And what are we supposed to do if it's more than a year? Since it's more than a year, we use 1 year. So that means when we find the future value, It's going to be $7,000 times 1 plus 0.053 compounded quarterly, so divided by 4 to the power of 4, 1 year. 4 times 1. Most people are going to plug 48 in there because it's 12 years, but we only go for 1 year. Which gives us 7378.44 is our future value. Which means our interest, 378.44. Now I skipped that subtraction. All I did is I took this and subtracted the original 7,000. Now this is the nice part on this one. The effective rate, we have the 378.44 equals, our principal was 7,000 times our rate times our time is 1 year. So 7,000 times 1 is just 7,000. You sound doubtful that there's something that could actually be easy in this class. So we divide by the 7,000. So 378.44 divided by 7,000. That did not work. Let's do it again. 378.44. 7,000. .054062. Works for me. Move that decimal point over 2 spots. 5.4062 or 5.41%. Okay, now that I've shown you the little trick for more than a year, time to let you guys try one. Actually, I'm going to have you guys try 2. No comment. So find the effective rate for $5,000 at 7.2%, compounded quarterly for 3 months. Find the effective rate for $5,000, compounded quarterly for 763 years. It doesn't really matter. At 7% compounded quarterly for 700. Okay, the first one here, what did you get for an effective rate?
22.
Why is the effective rate still 7.2%? Well, there's 3 months and a quarter, but it's quarterly. So it's just a quarter. There's no compounding here. It's 5,000 times 0.072 divided by 4 to the power of 1, because it's only 1 quarter. Which gives us 50, 90, right? So $90 is our interest. So it's 90 equals 5,000 times R times 1/4, right? Or 3/12, however you want to put it. So what's 1/4? 5,000 times 1/4 is 1250. $90 divided by 1250 is 0.072 or 7.2%. There is no compounding. It's only one interest period. There's no way the effective rate can be any different than the stated rate. I may not be a very nice person. Now, the other one, it is going to change. We're only going to go for 1 year, however. So our future value is going to be 5,000 times 1 plus 0.07 divided by 4 to the power of 4, because it's just 1 year. So 53, 59, 30. Oh, that's okay. So our interest is 359.30 equals 5,000 times R times 1. So we just have to divide by 5,000. So 359.3 divided by 5,000 is 0.07186. Move that decimal point over. 7.186%, which is 7.19%. I think it's time to take our second break at 7:18. I'm gonna have them cut the connection to Richmond so we don't have to listen to the vacuum cleaner. So we've got the effective rate down. Next, we've got a couple of other types of compound interest to worry about. What we've done so far is quarterly compounding or monthly compounding. There is annual and semi-annual, and I'm sure you guys can figure those out, right? Annual, N equals 1, right, because it's once a year. Semi-annual, N equals 2, twice a year. You're thinking bi-monthly. Yeah. So we have also compounded daily. What's N going to equal? 365. Very good. In compound interest, that whole 360 stuff is gone. There is no ordinary and exact. In compound interest, a year is 365 days. Yes, you can use the formula. Let's say we have $6,000 at 4% compounded daily for 2 years. The formula will give us a result for this. The future value. Yes. How many? It's 365 times 2. Because it's compounded daily. N is 365. Yeah, the 360 doesn't apply. That's only for simple interest. Oh, I'm not looking at effective rate here. I'm just looking at future value. Yes, that's a good question. We are only finding the future value. We're not looking for effective rate. Good question. So this is 0.04 divided by 365 to the power of 2 times 365, or 365 times 2, really it should be. N times T, N is 365 times 2, which is, yes, 730. $64.99.69. No problem. We'll wait for it. Any questions on how we got that? Okay. Well, there is another handy dandy table in your book. And I say that a little sarcastic because I don't really like this table. On page 471. This table, if you look at the top, compound interest on not $1, but 471. Yes. Compound interest on $100. So that's one of the differences. This is not per dollar, it's per $100. And it doesn't say future value, it just says compound interest, right? So what we're finding here is not the future value, it is just the interest. So there's two things that have to change here. The first thing that changes when we use the table is it's per $100. So we take our present value and divide by $100. We're going to use 60 here. Because 6,000 divided by $100 is 60. There are 60 hundreds that we're working with. Next, we look up our little term in the table. It was 4%, right? So 4% is going to be along the top. We might have to go to the next page. And 730 days or 2 years. So we find 4%. 4% not on the table. Are you killing me? It goes from 2.5 to 5. Wow, then that's something that they changed in the new edition. Wow. So we can't do 4%. Well, then we have to do a new example. Find the future value of $8,000 at, I guess we go with 5% compounded daily for 2 years. So it is 5%, and it's 730, which give us what little factor on the table here? $10.516335 is correct. Now we're not going to multiply 8,000 by that. We're going to do 8,000 divided by 100, which is 80. Remember, because it's per 100. This is compounded daily. The table. This is the table on page 471, 472 for compounded daily interest. Oh, that's 2 years. 2 times 265. So we're going to take the 80 times 10.516335. That gives us 841.31. Now, obviously, that's not the future value. That is the interest. So the future value is found by adding that back to the principal of $8,000. Now I'm going to pause for a breath here to let you catch up. Well, and it is exact. This table is actually much more accurate because it goes off $100 instead of per dollar. Yeah, if we do the formula, it's 8,000 times 1 plus 0.05 divided by 365 to the power of 730. And it should come out $88.41.31. Yes, that's because 100% plus. There's also continuously compounded interest. Put your pencils down for a second. The future value of continuously compounded interest is equal to the present value times e to the power of r times t. You guys have not angered me to the point that we're going to put that in this course. If you were to get into, if you were going to get into finance, and I mean beyond, we have a 2-year finance degree here. We would not quite get into this in the 2-year. They would mention it, but they wouldn't work with it here. If you were to go on to like a 4-year finance business administration degree, you would get into that something called the force of interest. They refer to it as. If you're going to get into the people, the big time accountants and financial officers of large corporations that calculate, all the stuff what they have to charge for products and stuff like that, they deal with that a lot. There's a field out there called actuaries. Actuaries are like taking a financial advisor and an accountant, crossbreeding them and putting them on steroids. They're the ones that sit at insurance companies and calculate what they need to charge you for premiums to make a profit, or for other companies figuring out, is this investment, if they want to build a new factory, how long is it going to take to recover their money? What are the costs? Would that beat what they could earn investing the money in a market somewhere? I mean, those are the people that do all those huge financial calculations like that. Yeah. Actuarial? Yeah. Yep. I've actually completed the first 2. There's 12 actuarial exams to become certified. They're actually in the process of changing. I've completed the first 2 actuarial exams just because the first 2 are pure math. So I did it for fun. Well, just to say I did it. But it's actually, this type of stuff is what the first exam is about, is the compound interest and annuity calculations and stuff like that. Daily? $8,000 divided by 100 to get the 80. Yep. It was 5% in 730 days for 2 years. So then you did that, and the chart gave the 10. Okay. So yeah, like I said, that's a great, if your kids or any of you that are going into accounting or finance, that's a great option if you continue going. It's something I've probably considered as a career. One of the reasons I've taken the exams is when I retire here, I'll be 55 to 57 years old. Everybody needs a hobby when they retire. And that's a hobby that, well, once you've passed, like I said, there's 12 exams. Once you've passed the first 6, you can work from home and work for pretty much any major corporation in the United States. There's only 25 people in the United States that have passed the first exam. 25,000 people that have passed the first. What's that? There's only 15,000 that passed all 12. So it's almost if you can pass them, you're in.
Multi-million-dollar
Customers.
she has to deal with all of this every single day. And I'm like, my sister was actually diagnosed dyslexic. I'm like, how do you do it?
Well, the main reason I deal with numbers, I do math, physics, and engineering are my degrees. The reason I was actually a very good writer when I was young. I won a lot of writing contests, had scholarships for the School of Journalism, but I couldn't keep up reading because I was dyslexic. Math, physics, and engineering are the only textbooks that nobody can read fast, so they're the only topics I can keep up in.
And she read backwards.
Sure.
Numbers
We're okay.
perfect.
Have you always been good at math, though?
Yeah, it makes sense. Okay. Okay, so now we still have our timeline. At the beginning of our timeline, we start out with that present value. At the end of the timeline, we end with a future value. And in between, we have compound interest. However, now we're going to start looking at what if we know we need a certain amount in the future? We want to know what we would have to start putting away now. For example, Pat wants to start a college account, a college fund for their newborn child. Pat figures $40,000 will be needed. In 18 years. So we're assuming the child's newborn will go to college at 18. The account will earn 8.2% compounded semi-annually. How much does Pat need to put away now? So what we know is this is the amount up here, the 40,000 that we want to have in the future. The compound interest is going to be the 8.2% semi-annually. For 18 years. We're trying to find what we need to start with. So we're going backwards. Now this formula is way easier than you would think. The formula we just used was the future value is equal to the present value times 1 plus r divided by n to the power of nt, right? That look familiar from about an hour and a half ago? Okay. What if we want to find the present value? Well, if we want to solve for the present value, it's being multiplied by this factor. We just have to divide that factor out, right? So what that gives us is a formula for present value. where it is equal to the future value, but instead of times, it is divided by 1 plus r divided by n to the power of n times t. So for our friend Pat up here, that present value is going to be the 40,000 that they want to have in 18 years divided by parentheses 1 plus, what's our rate? 8.2% becomes 0.082 divided by how many periods in a year? Semi-annually will make it 2. N is still 2 and T is 18 years. So again, I'm going to 2 times 18 is 36. So 40,000. We have to remember to hit divide now instead of times. Parentheses 1 plus 0.082 divided by the 2 for semi-annually, the power of 36. 94, 15, 29. So to accomplish that $40,000, Pat would have to put away a little over $9,400 right now. What do you think?
Well, and you just have to make sure that you put that divided
Instead of
before
multiply.
the parentheses.
Yes.
Or it's automatically multiply.
Yeah, you have to put it before the parentheses or it's going to multiply. Let's say Sam just inherited a lot of money. We don't need to know how much. Sam wants to put money away so their son will have $15,000 to buy a car in 4 years. At 3.1% compounded monthly. How much should Sam put away? I think you guys can handle this one on your own. I'm going to give you a couple minutes. So that present value is going to equal the future value of 15,000. Here's the big thing to remember. Divided by parentheses 1 plus 0.031 divided by 12 because it's monthly to the power of 12 times 4, which is 48. So 15, 1, 2, 3, divided by 1 plus 0.031 divided by 12 to the power of 48. That is correct. $13,252.82. What do you think? I have 2 questions I want you guys to answer in your notes. If we feel good about them, we're going to call it a night. Find the effective rate for 8% compounded monthly for 7 years. Doesn't matter. Pick a number, whatever number you want to pick, and put it in there as the principal. Somebody said 10,000. That's a great, nice round number. That's what I usually use is 10,000. The second one is going to be find the effective rate for 8% compounded monthly for 10 months. Now, before you start doing a lot of punching in, which one should be larger? Which one's going to compound more times? 7 years. Now, remember, if it's more than a year, we use 1 year. Okay, I'm going to pause this. I'm going to give you a few minutes. So for the first part here, find the effective rate, 8% compounded monthly for 7 years. We're just going to find the future value. It doesn't matter what number we pick. I'm going to do $10,000 times 1 plus 0.08 divided by 12 to the power of 12, because we're only going to go for 1 year. I get a final amount of $10,829. Oh, actually $10,830. So that means I have $830 in interest. So 830 equals 10,000 times R times 1. Dividing by the, I'm going to skip combining the 10,000 and the 1 because we all know that's just 10,000. Dividing by 10,000, that's 0.0830. So that gives us an effective rate of 8.30%. How many of you had that? Any questions? Anybody have no clue how I got that? Anybody want to cry a little? No. Okay. The effective rate on 8% compounded monthly for 10 months. How many of you need a couple more minutes? Are we ready? Let's do it. So that future value, I'm going to use $10,000 again. 1 plus 0.08 divided by 12, only now it's to the power of 10. So we get 10,687.03. So the interest, of course, is the $687.03. So that equals our 10,000 times R times, of course, 10 twelfths because it's 10 months. So this 10 twelfths is going to be a little bit ugly. Yeah. So now we're going to divide by the $8,333.33. .08 what? 2443. So we move our decimal point 2 spots. That's 8.2443% or 8.24. It is slightly lower than this one because it only went for 10 months instead of the full year. So that's the key is if it's more than a year, you only figure it out for 1 year. If it's less than a year, you have to use the exact time. Any questions? So there is a new quiz that is due tomorrow, Thursday. at 11:59 p.m. There's a new homework. It'll be due for next Wednesday at class time. Also, we only do have 3 classes left after this. 2 of those classes will be lecturing on annuities and sinking funds. The 3rd class will be our last test. It will not be cumulative. It'll only be on Unit 3, these last 5 or 6 weeks of lecture. Since we are approaching the end of the semester, anybody who has had to make up any quizzes, the system, my math lab, is really tricky to look at. Once I've transferred grades from my math lab to Blackboard, it doesn't give me an alert of new grades or anything like that. So if you've made up a quiz, please double check and compare your My Math Lab to the gradebook in Blackboard, because the Blackboard gradebook is the official gradebook. And make sure that I did find it and transfer it over. If I didn't, send me an email saying quiz number whatever has been redone. You know, if it's one that you missed and did late, or even if it's one that you redid for more points, let me know. Also, with 3 weeks left, if there are quizzes that you have low scores on, like less than 80%, I mean, less than 90% even would be worth redoing. Let me know if there's something that you have time and would like to redo some of those quizzes. Let me know. I will still let you redo them and make them up. There is a penalty if it's one that you just didn't do. You'll be working at 80% would be your max grade, but 8 out of 10 is better than 0 out of 10. If it's one that you've already done your 2 attempts on and want to redo it, I average that grade with whatever your old score is, unless it's lower. If you get a lower score, I'm just forget it happened. But if you get a higher score, I average your 2 highest scores together then. Your corrected tests will go in here in the next week. Okay, you guys have a great